We are in the arena, the flying machine arena at Zurich's ETH University in Switzerland. And a quadrocopter is about to show us what it can do. Can it zigzag through the poles all by itself?
So you'll see at the very beginning, it didn't fly around the poles. The quadrocopter realized this error and mathematically corrected for it by applying for more thrust when it needs to make these turns.
So it's learning all the time?
It's learning all the time. It's continuously improving itself.
Practice, or at least repetition, makes perfect. ETH is one of the world's leading technology universities.
All right, one more, guys.
Professor Raffaello D'Andrea runs a research project exploring robot movement in the air. Machine athleticism, he calls it.
We always set our sights on creating things that have never been created before. It's like a triumph of humanity. Look what we can do, right? Look what we can make these inanimate things do. If we can do this, we can do anything.
Since 2009, the arena has been a space where, as they say, flying robots live and learn. Learn, that is, to move through the air all by themselves without remote control. The quad can balance a pole, no problem. It's not so easy for a human to balance. How does the machine do it?
Well, it's actually doing something that's very similar to what you're doing right now to balance it. The first step is that it needs to watch what's happening. The pendulum has a gray marker on top, and there are cameras up above that can see this marker and report this information back to the computer. What you're doing is using your intuition on how you expect this pendulum to move. What we use for the quadrocopter is that we develop a mathematical model of how this pendulum moves in conjunction with the quadrocopter.
Those mathematical models are based on a series of algorithms that act as a language telling the robots what to do. The ones developed here are the most complex in the world, allowing the robots to perform gymnastic maneuvers never seen before, like throwing a pole, building a wall, or catching a ball.
Algorithms take information and they produce action in the context of machines. That's what algorithms are. It's rules. How do I take information, input, and convert it to actions so that the machine does something interesting?
All this movement begins on the page, a pencil across a piece of graph paper, writing out complex mathematical equations that translate to movement in the air.
And mathematics can be very elegant. When you come up with a really nice algorithm, the mathematics tends to be also very elegant. The two things go hand in hand. In fact, there's a strong correlation between watching these vehicles do something graceful and beautiful and how beautiful the mathematics is that achieves it.
Predictably, some of the arena stunts have gone viral on the internet. Playing catch is one of them. For this to work, the relevant algorithm has to make 50 different calculations every second. Where the ball is going, how the quad should get there, how it should hit the ball back, and so on. All pretty complicated mathematical stuff. If only I could lob the ping pong ball in the right place, just occasionally. They hope it can be used eventually for entertainment, search and rescue operations and traffic surveillance, to name a few. His team of soccer-playing robots that won the Robo Cup Championship in 2005 were developed and sold to Amazon for $775 million last year.
Is there a difference between working on the ground and creating robotic movement on the ground and in the air?
Now you're working in 3 dimensions instead of 2. So you can do more things, but the equations of motions are more complicated and your choices are much larger. Therefore, the algorithms tend to be more complicated. If you're doing very aggressive motion with these vehicles, the aerodynamics is extremely complex. So that leads to other complications.
In the arena in Zurich, it seems somehow both serious and playful. Research project and playpen for the boys. Whoever thought that calculus, algebra, physics, control theory and the like, and algorithms could be this much fun?
I celebrate motion. I think it's a wonderful thing, whether it's humans that do it or machines that do it or the mathematics that captures it. I love motion.
We'll never lose our fascination with the birds. How could we? but we're also teaching little machines to fly about in ways that sometimes seem just simply astonishing.
Amazing.